Hello guys and welcome to Tech Toffee.
In our previous video, we have created our prime numbers list, which is giving us the results. When 2 is passed, it will return that it is a prime number. When 4 is passed, it will return not. But here the problem that we face is if we create a test where the number is not present in the prime numbers list, but if it is a prime number, then it will return false. So for example, here we are creating a number 573, which is not a prime number, but 919 is a prime number. So if we pass 919, we expect that it should return true because 919 is a prime number, and if we are passing 573, it should return false because it's not a prime number. Now if we run it, it will show that 573 and 919 both are not prime number. So but we know already 919 is a prime number. So the problem here lies inside the is prime function, where we are reading the numbers from a list of prime. So here what we can do now is we can create a function, a for loop basically inside this function, to check whether a number is prime. So the best way to do it is any number is a prime number if it is not divisible by any number apart from itself and 1. So we have to check for each. So we have to check if if a number is divisible by 2 or any number between 2 and that number, it will be a prime number. So we are checking the mod of that and returning false here if it is not a prime number, and in other case we are returning true. So now we are not at all using the existing list, and we are calculating for each of the function here. Now if we try to run it, our all test cases should be a pass. Now the situation occurs is like we have to calculate the execution time of our function. So we will create a wrong variable which will have system dot nanotime. So it will basically what is the nanotime before this for loop is executed and what will be the nanotime after this for loop is executed, and after that we will calculate that what is the time taken in nanoseconds to calculate it. So system.out.print, we are printing that what is the time taken here. So time taken will be end minus start. And now if we run it, we can see that what is the time taken by each function here. So we can see that any number which is a prime number, it is showing that how much nanoseconds it is taking. Now to convert it into microseconds, we have to divide it by 1000. If you want to convert into milliseconds, you have to divide it by 10 lakh. So here we are dividing by 10 lakh and we are printing the time in milliseconds. Now if we run it, we can see that for the numbers that are prime, where true is expected, that what is the time is taken. So it is saying 0 millisecond because the time taken for this calculation is very less. So let's make it as microseconds, and then we'll see what is the time difference between the two calls. Since we know that when we are expecting 2, it is a very small number, so it should be lesser time than when we expect 919. So now if it runs, we already added it to the non-primes also, so we can see that for 2 it is taking 0 microseconds, and for 919 it is taking some 123 microseconds approx. But this is a system time, so this can vary with every execution, since there can be system interrupts and since the processor is working on other things also. But is there a way to further optimize this code? That we need to see now. What if the number is even bigger? So consider there is a prime number, say 9973. So 9973 is a prime number. So we expect the result to be true. But now if we run, the time taken by the function here is 976 microseconds. So 976 microseconds is the time taken for 4-digit number, to check whether a 4-digit number is a prime number. We know that if a number is not divisible by half of its value, then it will not be divisible by any number after the half. Basically that. So this will improve our time much, because we don't have to go that much. So now you can see that the time has increased. So this is not the case actually, because this happened because of the system interrupt. Maybe some other process has started which has made this as in waiting state. Now if we run again to get the exact time, what better time it takes. So now we can see that it took 353 microseconds, which is a improvement from last time when we saw 900 something microseconds. Now to improve it further, can we actually improve it further? So to check that, what we can do is, we know that prime numbers can only be divisible by any number which is less than or equal to its square root. So if it is not divisible by any number which is less than equal to its square root, then it will not be divisible by any number further. So this will further increase our time, further decrease our execution time. So now we can see 32 milliseconds or 8 milliseconds is the amount of time that is actually being taken here. So this is how we have optimized this function from 900 milliseconds to 200 to 300 microseconds.